1785, Thomas Edison was experimenting with the electric light bulb he had invented 6 years earlier, and discovered that a metal wire placed inside the bulb and near the hot glowing filament produced a current flowing from the filament to the wire. Experimenters found out later that if metal is heated to incandescence, that is until it glows, electrons escape from the metal. These electrons form a negatively charged cloud around the filament called a space charge. This was called the but today it is known as thermionic emission, or the discharge of electrons due to heat. In England in 1906, Ambrose Fleming made use of the Edison effect by surrounding the filament in a lamp with a metal plate which picked up electrons from the cloud. The cat's whisker used in a curved wireless set as a detector was replaced by the electron tube when it was found capable of detecting very weak radio signals. In the United States connected a battery between the plate and the filament so that the plate had a positive charge. This attracted more electrons from the space charge and increased the current flow to the plate.
The first next step was to add a fine wire in the filament. The great because of its close proximity to the filament caused a great engine
to the plate, and the tube became a control device. What ConneXionic has given us the variety of vacuum tubes which we have today.
Tubes used to control the
flow of electrons.
The electrode
is called the cathode. Simplest type of cathode is the filament. Many tubes have a cathode which is heated by a separate heater, providing more electrons with less heat. The cathode is surrounded by a plate which collects the electrons. It is called the anode. The electrodes are placed in a glass or metal envelope, and the air is removed from it. A tube with 2 electrodes is called a diode. When the cathode of a diode is hot and the potential or voltage of the plate is positive with respect to the cathode, electrons flow. If the plate is negative in comparison to the cathode, electrons are repelled by the plate. In this way, acts as our one-way separate. The grid of comparison needed so that the electrons pass through it to the plate. If the useful electron field required, if the group equal in charge, the electrons pass through easily. If the grid potential is slightly negative compared to the cathode, electrons attracted by the plate have difficulty passing through the grid. If the grid potential is sufficiently negative, the electrons will be completely blocked and the plate current will be zero. The performance of the triode can be improved by adding another grid closer to the plate. It improves the tube's ability to amplify. It is called a screen grid. And the tube becomes a tetrode because it has 4 electrodes. Other grids can be added to do various jobs. For instance, we can add an extra grid to the tetrode to stop a reverse flow of electrons from the plate. This is a suppressor grid, and the tube is now called a pentode because of its 5 electrodes. The pentode is one of the most commonly used tubes in modern radio and television sets. In the RF stage as a voltage amplifier, and in the power output stage as a power amplifier. Although there are many different types of electron tubes, their basic components are the same. A tube's electrode system consists of an anode, a cathode, and grids. The number of grids will vary with the job the tube must do. The cathode emits or gives off electrons when it is heated. The cathode is coated with a material that makes it easier for the electrons to be emitted. The grids are usually wire mesh. They control or block the flow of electrons. But in some tubes, they are also used as anode or cathode. When tubes are manufactured, all components are separated by an insulating material like mica. The components are mounted on a base and inserted in a glass envelope. Air is then drawn out of the envelope, and the components are sealed in a vacuum. Tubes and their components can be identified or marked on diagrams. This is the cathode. This is the anode or plate. This symbol is used for a grid. And this one identifies the heater or filament. This symbol identifies a diode. This is a triode. This is a tetrode. And this is a pentode. In a tube manual, you will find each pin of the tube numbered to indicate the component to which it is connected. In some cases, you may not wish to use all elements of the tube. The manual tells how when an alternating voltage is fed into a diode tube circuit, pulses of direct current will result, since electrons flow through a diode in one direction only. When the plate potential is negative, there is no current. When the plate potential is positive, electrons flow. A rectifier changes alternating current to direct current. Using a diode vacuum tube, when the anode of the diode is positive in comparison to the cathode, electrons flow from cathode to anode to the load during alternate half cycles. This is called pulsating direct current. By using two diodes operating on alternate half cycles, we can make full use of the alternating current power and obtain a smoother flow of current. In this circuit, a center tap transformer supplies voltage to the anode or plate of each tube. Because the plates are supplied from opposite ends of the same winding, the first half of the cycle, the plate of one tube is positive compared to the center tap, forcing the electrons to flow from the center tap through the load and that diode. In the other half cycle, when the polarities applied to the diodes are reversed, the electrons will flow from the center tap through the load and the diode whose plate is now positive. So one tube is conducting on each half cycle, with the flow of electrons in the load not changing direction. Here is a comparison between the input voltage and the output voltage. A center tap transformer and a twin diode are often used to rectify in a radio. A twin diode is simply a single vacuum tube designed and constructed to contain two diodes. The development of the triode tube has made it possible to use small signal voltages to control larger, more useful voltages. This is the symbol for a triode. The small signal voltage is applied to the grid, and as the grid voltage varies, it causes a much larger corresponding change in the plate voltage. So the tube is increasing or amplifying the original signal. Let's put a triode to work as an amplifier. In most circuits, the grid is kept slightly negative to the cathode to avoid distortion of the signal. This is called grid bias voltage. We will apply 6 volts for this tube. The incoming signal is fed into the grid circuit of the triode. In the plate circuit, we need a higher voltage, 90 volts for this tube. To keep the plate positive, we'll connect the positive side to the plate and the negative to the cathode. The output signal of the tube can be fed to a transformer. That completes the plate circuit. You can see how both grid and plate circuits go through the cathode, but their polarities are opposite. Finally, we need a power source for the heater in the tube. It is separate from the grid and plate circuit. Let's look at the incoming signal on the oscilloscope. In this case, a low voltage from the audio generator. The strength or amplitude of the output signal is much greater, but the form is the same. The triode is amplified. Tubes like this amplify small signal voltages. But power amplifying tubes must produce the best combination of current and voltage output. These tubes have a heavy filament and a larger plate to handle the higher current required for this job. The power amplifier uses the incoming signal voltage to control heavy current to a load, as in the case of a transmitter tube. In this basic power amplifier circuit, there is a triode, an input signal, a power source for the grid bias voltage, and the heater. And an output transformer in series with the plate supply voltage. The positive half of the incoming signal, the upper part of the sine wave on the oscilloscope, makes the tube conduct current in the plate circuit. But the negative part of the signal cannot pass. The negative part of the signal makes the grid more negative, and this prevents the flow of plate current. If we want to amplify the complete signal, we can add a second similar tube, and use an input transformer with a center tap on the secondary winding, and a center tap output transformer. When one half of the cycle goes through the primary coil of the input transformer, the polarities in the two halves of the secondary will be opposite. The upper tube is passing current, the lower tube is not. On the other half of the incoming cycle, the polarities of the secondary coil are reversed. So the action of the tubes is reversed. Now the lower tube is passing current. This means that in each half of the cycle of the input, one of the tubes is conducting. It is combined in the output transformer to feed the load. There is a continuous current in the output transformer, and on the oscilloscope, it looks like this. We have talked about the diode and triode tubes, but there are many other tubes that are built to do more than one job. These are called multiple electrode tubes. For instance, the hexode has 6 electrodes, and 4 of them are grids. The heptode, a 7-electrode tube, has 5 grids. Because a wide range of frequencies cannot be amplified efficiently in a receiver, they must be changed to one frequency. One of the main jobs for these tubes is frequency changing. In radio receivers, the incoming frequencies are converted so that each signal can be amplified without losses. Here we are using a hexode as a mixer. In a super heterodyne receiver, the incoming RF signal is mixed with a different frequency produced in the receiver itself. This new frequency, the IF, is equal to the difference between the frequency of the incoming signal and the frequency produced in the set. Then this lower difference or beat frequency is amplified. There are two types of frequency changing circuits. In one, the local frequency is produced in a triode tube and is combined with the incoming signal in another tube called the mixer. Another system uses one tube, usually a heptode with 5 grids. The first two grids act as the grid and anode of a triode to produce the local frequency. The incoming signal is fed to one of the other grids. So the heptode does the job of two tubes, an oscillator and a mixer. Another multiple system tube is the twin triode, which is used as an amplifier in a television channel selector. We have described the more familiar applications of electron tubes. In science, complex electronic measuring instruments also make use of the electron tube. The Geiger counter is one well-known application. This complex radiation counter is another use of the electron tube. Tubes are used in the oscilloscope as a detection device and in the control and storage unit. Manufacturing processes use the electron tube. It can be used in circuits to detect temperature or pressure changes, or to control the timing and process of industrial operations. An alarm system like this smoke detector, which uses a photoelectric cell, is another example. Here, particles in the smoke interfere with the flow of current